Chapter 8, Chemical Equations and Reactions. Chapter 8, Section 1, Describing Chemical Reactions. So if we think back to chemistry when we first started, we talked about chemical changes. So a chemical change is when we take two substances, we put them together, we create something different. A chemical reaction is the same thing, and we express a chemical reaction by writing a chemical equation, which we're going to get to in class. Examples of chemical changes that we've talked about: iron rust, milk turns sour, your car engine runs and burns gasoline. So a chemical reaction is the process by which one or more substances change into one or more new substances. If we think back to Chapter 5, we looked at taking sodium, so a silvery white solid, combining it with chlorine, which is a yellow-colored gas. So those would be our reactants. We combine them together. We make a white crystalline solid known as sodium chloride, which would be our products. Those reactants have very different properties than the product. The reactants, sodium is very reactive with water, chlorine's a poisonous gas. We combine them and we use it to season our food with every day. So this video is going to show the reaction of aluminum and bromine combining to make aluminum bromide.
When liquid bromine is added to aluminum foil, the two substances react. Heat and light are indications of a chemical reaction. Aluminum bromide is produced and deposited onto a cooler surface.
So you can see that aluminum, if we think of aluminum foil, is a silvery metal. Bromine is a reddish-brown liquid, and we combine them together and we get this crystalline white solid. So a chemical reaction, sometimes it's not always easy to tell that it has taken place, but we can definitely see some signs that tell us a chemical reaction has taken place. So let's think about something that's in your everyday experience. So if we think about wood burning, and all the signs that tell us that a chemical change has taken place. You see smoke, you see light, you feel the warmth, you can see the surface of the wood change color, and then when it's all done, if you look what's left in the fire pit, you have a gray powdery ash. So this video clip, we're going to click on each of the thumbnails, and it's going to give us evidence that we look for that a chemical reaction has taken place.
Sometimes a chemical reaction will make gas. If this occurs in a liquid, you might see bubbles. For example, when we add vinegar, an acid, to a solution of baking soda, which is a base, a lot of fizzing occurs because carbon dioxide is released. Some chemical reactions produce a precipitate. When a solution of blue-tinted Epsom salt is added to a solution of water and household detergent, a precipitate forms. A color change is also a useful indication of a chemical reaction. Indicators, such as phenolphthalein, change color when a solution reaches a certain pH. We can tell that certain chemical reactions have occurred because the pH of the solution has changed. The production of heat or light is a strong indication that a chemical reaction has occurred. Fireworks are a good example of a chemical reaction that produces heat and light.
One of the terms mentioned in the previous animation was the term precipitate, and as a reminder, a precipitate is an insoluble solid. So in other words, it's a solid that will not dissolve in water. Okay, so in the animation before, it had told us indications of a chemical reaction. So I'm going to list them for you so that you can record them in your notes. So again, this is proof to us that we have made something new with its very own unique properties. So one example is the evolution of energy as heat or light. So if we look at this, we can probably think back to first semester chemistry and think of the wish bottle. It doesn't necessarily have to be the evolution of energy either. It could be that it absorbs energy, so the outside of that container would feel cooler. Production of a gas. So we've seen vinegar and baking soda react in first semester chemistry. We saw bubbles of carbon dioxide gas given off. Here, this is zinc and hydrochloric acid. Again, we see bubbles. In this case, the bubbles are hydrogen gas. Formation of a precipitate. So in this picture, there are two colorless solutions being combined, and the yellow substance you see here is actually a yellow precipitate. So in other words, it's a yellow solid that will not dissolve in water. And number 4 is a color change. Most often the color changes we are going to observe in class is going to be due to an indicator. However, when we look at the next video, we're going to see ammonium dichromate volcano. So initially it's going to start off with being an orange solid, and you're going to see as the reaction takes place, we make a brown solid. The other thing we're going to observe is light. Okay, the last thing we want to talk about is we really want to focus on these energy changes that occur in terms of a chemical reaction, and that how that's going to affect our balanced chemical equations. So we know from first semester chem that energy can be released in a chemical reaction, and we say the term that applies to this is the term exothermic. And if we look, if I take a hydrocarbon, react it with oxygen, this gives me carbon dioxide, water, and its energy is a product. Okay. It's being released, so we write it on the product side of the equation. Energy can also be absorbed, and the term that applies here is the term endothermic. So in this reaction I have dinitrogen tetroxide reacting with energy to give us nitrogen dioxide. So in an endothermic reaction we see energy written as a reactant. So one of the things we're going to focus on in class when we write our own balanced chemical equations is if energy is applicable to our equation, where do we write it? Do we write it on the reactant side, or do we write it on the product side? So really the terms endothermic and exothermic are a review. If we're absorbing energy or taking it in, the term endothermic applies. And if we're releasing energy or giving off energy, typically we would see this in the form of heat or light or sound. This is exothermic. Now, not all chemical equations have to be endothermic or exothermic. So if the energy is not significant, then we don't record energy as either a reactant or a product.